Let's solve the rational inequality and graph the solution on a real number line. Alright, we're starting with x minus 5 over x minus 3 is greater than 0. Alright, the first thing I have problems with is this x minus 3 on the bottom. X minus 3 on the bottom is going to give me a domain concern at x is equal to 3. X is equal to 3 is bad. So whenever we do a final graph, 3 must be open. Okay, it is going to be open because it's a domain problem. As far as the rest of it goes, we're just going to take the fraction and solve it as if it's an equal to problem to find some other critical points. You'll take this x minus 3 on the bottom here, you'll cross multiply it up, just make it go away. Here we're going to get x is equal to 5. Now 5 is going to be open because the original problem did not have the equal to sign. So this one is also open. They're open for different reasons. This one is open, the 3 is open because it's bad. It's a domain concerned. The 5 is open because of the lack of an equal sign, which doesn't have a D in it. Sign. And then what we'll do is we'll pick a point in one of these regions, and the shading should just be an alternating pattern. So I'm going to check the easiest point of all, 0. So I plug a 0 into the problem. I get 0 take away 5 over 0 take away 3. Is that greater than 0? This will be negative 5 over a negative 3, which will be positive. Positive 5 over 3 is definitely greater than 0. So we will shade here, but we won't here. And then we'll shade again here. So we're looking for a region where we have parentheses, so no brackets. So parentheses for the open circles, and that is C. Number 4, a lot here. Use the vertex and the intercepts to sketch the graph of the quadratic function. Give the equation of the axis of symmetry and use the graph to determine, okay. So the vertex is going to use the formula negative b over 2a to figure out the h value. So that'll be a positive 32 over 2 times the a, that'll be 8. So we have a 4. So your vertex. To find our k value, we'll take and plug that 4 back into the function. So that'll be 4 times 4 squared minus 32 times 4 plus 66. Now we do not get a big calculator, we get a little calculator. So 4 times 4 times 4, that'll be my 4 times 4 squared minus 32 times 4, 128 plus 66. Clear. 64, take away 128 plus 66 is a 2. 4 comma 2 is our vertex. The way this graph would work, we'd have 1, 2, 3, 4, 1, 2. That would be a minimum point, and right through here you'd have a line of symmetry. That line of symmetry is a vertical line, and it's going through x is equal to 4. So the axis is x is equal to 4. The y-intercept is always going to be this little rascal right here on the end of the equation, be 0, 66. The x-intercepts are, we'll figure those out by solving this equation. It's not wanting to scroll. by solving this equation. So let me erase my graph here, and let's solve 0 is equal to okay. I'm going to go through and at least divide everything by 2. I wish I could divide by the 4. That's most likely factorable, but I'm going to go to the quadratic formula. X is equal to a negative b plus or minus our b squared minus 4 times the a times the c, all of that over 2 times the a, 16 plus minus 2, 5, 6, take away it's not going to work that way. 4 times 2 times 33, 256. I don't remember that number. 4 times 2 times 33, 264. 256 minus 264 is going to be something that's going to give us imaginary. So I'm going to stop, and there are no x-intercepts. And we should have known that anyway, because when we graphed it, the point 42 had us in the first quadrant. There's no way it's going to come down to the touch the x-intercept. Okay, so choose the I don't know why it won't scroll. So choose the correct graph D here, because if you remember, the vertex was 4, 2, and that's not any of these. The domain of any polynomial function is all real. Your range is going to be based on that y, that vertex, this y right here. So you are at 2 and up, and that would be letter A. Sorry for the gaffes. I like soup.